Okay, this is your first lesson for Chapter 2, Rational Numbers. This first lesson is going to look at comparing and ordering rational numbers. So by the end of this lesson, you should be able to know what a rational number is, and then what a rational number isn't, so the difference between rational and irrational numbers. And then you should be able to know how to order rational numbers. So I could ask you to either write them in an ascending order, so smallest to biggest, or descending order, largest to smallest, and you would have to be able to do that. And then the third thing you need to learn from this lesson is how to compare rational numbers and decide which one has the larger or smaller value. And it's important that we think of value here, not just fraction size. So first thing I'm going to get you to do is take a look at your notes that you have printed out for you in your lovely booklet. And your first page should look like this. And so I want you to take a second and look in your textbook. Maybe you'll use the glossary, maybe you'll use information in the chapter, and I want you to find what a rational number is. So I'm going to pause this and give you a second to fill that in before I tell you. All right, so rational numbers can be positive values or negative values, or they can be zero. So zero would be considered a rational number. Rational numbers can be integers, they can be fractions, or they can be decimals. Now, if we're looking at a value that is a fraction, to know if it's rational, we need to put it into its decimal form. So when we look at the decimal form, it's either going to end, so we would call it a terminating decimal, it's going to end. Something that would be a terminating decimal would be something like 0.25 or 0.17. These are terminating decimals. The other type of decimal that is a rational number is a repeating decimal, and it needs to repeat in a predictable pattern. So something like 0.333 repeating, we know what the next digit's going to be. It's going to be a 3. Or 0.171717, we know what the next digits are going to be. It's going to be a 1 and then a 7. So the biggest thing to know about rational numbers is they are predictable. You know what comes next. So now that you know what rational numbers are, we need to be able to figure out which of these are rational numbers. So we have a few that we should be able to get right off the bat. So -2 is an integer. The number terminates. It's predictable, so it's a rational number. 0.875, it's a terminating decimal. It's predictable. It is rational. 0, we said 0 is a rational number. -0.8, again, a terminating decimal, so it is rational. So then we have two fractions, and we need to think of these fractions in decimal form before we can decide if they're rational or not. So in order to turn a fraction into a decimal, I need to remember that I go top divided by bottom, so 3 divided by 4. So when I go 3 divided by 4, 0.75, or I can think of 3/4, like in money, and I have 75 cents, so 0.75. So because it is a decimal that ends, we would call it rational. 2.5. So this is like saying we have 2 whole dollars and half of a dollar, so 2.50. Again, if we wanted to, we could turn this fraction into a decimal by going top divided by bottom. And again, we would get 2.50 or 2.5. Either way, it is a decimal that ends, so this also is rational. So all of these are examples of rational numbers. Some examples of numbers that aren't rational would be something like 0.563217. You don't know what's coming next because I made it up. So unless you can read my mind, you don't know what's coming next. So that would be an irrational number. It is not rational. It is not predictable. So we're going to put these values on our number line. The easiest one we're going to do first is 0. Because I know its exact location, I'm going to mark it with a closed dot. So that's where my 0 goes. The next value that's easiest to place is -2. Again, I know its exact location, so I'm going to mark it with a dot. The other ones are a little bit trickier, but they're easy to figure out. We're going to do 2.5, so I'm going to go up to +2, and I'm going to go approximately halfway between 2 and 3. Because I don't know the exact value, I'm going to mark it with a downward arrow. So 2.5. The next value that's kind of easy is 3/4. So 3/4 isn't a full dollar, it's between 0 and 1, and it's going to be closer to 1. So again, I'm going to mark it with an arrow because I'm guessing its location. I don't know exactly on my line, unless I took out a ruler, but we're not going to do that. So 3/4 is gone. So now I have 0.875. Well, if I compare the decimals of 0.75 and 0.875, 0.875 is larger. So 0.875 is closer to 1, which means it's going to have to be in here, in between 3/4 and 0.87 and 1, pardon me. So 0.875 is going to go there. The last value I have to place is negative 0.8. So again, it's between 0 and 1. It's going to be close to, or 0 and negative 1, pardon me, and it's going to be closer to negative 1. But again, I'm guessing it's approximate value because I don't know for sure. So the next thing you need to do once you have these values is I might ask you to put them on a number line, just like the last example, or I might ask you to write them in either ascending or descending order. So remember, ascending order is starting small and getting bigger, and descending order is starting big and getting smaller. So in ascending order, all we're going to do is we're going to read them from left to right, because -2 is the smallest value. The digit 2 isn't necessarily the smallest digit, but as far as value goes, it's the smallest value. Sometimes it helps to think of money. So -$2 in your bank account is the least amount of money on this number line. So we're just going to write them in order. -2, -0.8, 0, 3/4, positive 0.875, and then positive 2.5. And I'm writing them in the format that the question gave me, not the decimals that I created to compare them. So then if we said, okay, you need to do it in descending order, well, descending order is just this order, but in reverse. So positive 2.5, 0.875, 3/4, 0, negative 0.8, and then -2. Okay, so now we have two fractions we need to compare, and we need to decide which one is larger or which one is greater, meaning the greater value. So meaning if it was on a number line, it would be furthest to the right. There's two ways to do this. There's going to be sometimes I'm going to ask you to model one way or the other, but for the most part, equivalent fractions and converting fractions to decimal are grade 7 and grade 8 skills. So we're assuming that you know how to do this already. If this is something that you struggle with, I need you to come in and see me tomorrow so that way we can talk about it and practice it. So first way is equivalent fractions. So when we think of equivalent fractions, we're thinking about a common denominator. Again, if you don't remember what a denominator is, that's a problem for you and for me, so you should practice that. Denominators are the bottom of the fraction, or how many pieces it's cut into. So we need to be comparing the same size pieces. So the way that we do that, the easiest way that we can do that, is multiply the denominators together. We could also look at multiples, so count by 3s and count by 4s, and see where we get the same number. But the easiest way is to take the first fraction and times it by 3, because that's the other denominator. Take the second fraction, times it by 4, because that's the first denominator. So when we do that, we get the fractions 9/12 and 8/12. Well, now it's much easier to compare. We can easily see that 9/12 is greater than 8/12. So 3/4 is larger. The second way we can do this is by turning both fractions into decimals. And a reminder, turn a fraction into a decimal, numerator divided by the denominator, or top divided by bottom. So we're going to go 3 divided by 4, and we get 0.75. And we go 2 divided by 3, or 0.6 repeating. Because 0.75 has 2 decimal places, I'm going to write 2 decimal places for the 0.6 repeating, just so we're comparing the same number of decimal places. Okay, so now when we compare them, we have 75, and we can think 75 cents, or we have 65 cents. So again, 0.75 is larger, so 3/4 is larger. So now, when we look at this next example, we can use either the fraction method or we can use the decimal method. I've decided for A that I'm going to use our fraction method, and for B, I'm going to use the decimal method. However, if you decide to try it using a different method, we should both get the same answer. So I'm going to ask you to pause this video and try these two examples on your own before I show you the answers. Okay, so when we try example A, if we multiply the denominators together, we get a common denominator of 35. So we get the fractions negative 14 over 35 and negative 20 over 35. So we're looking at negative values, and we want to think which one is the greater value. So greater value is always the one that is further to the right. If we're thinking on a number line, 10 is further away to the right than 5 is, so 10 is the larger value. Same thing with negatives. So if we have a negative, we want the one that is further to the right or closest to 0. So in this case, negative 14 over 35 is the larger value because it's the one that's further to the right or closest to 0. For example B, I hope you noticed that you had mixed numbers. So you have a whole number, which is 3 in both cases, and then a fraction, which represents your part of a number. Again, I recommend that you look at the same amount of decimal places. So in this case, when I went 3 divided by 5, I got 6. It's just 0.6, it stopped. When we did 2 divided by 3 in the blue example, we got 0.6 repeating. So if we were thinking this as money, this would be 66 cents, and 3 3/5 would be 60 cents. So now when we're thinking, okay, which one is smaller? Well, $3.60 is less than $3.66. So 3 3/5, not 3/3, 3 3/5 is the smaller value. And again, when we're thinking of smaller values, smaller means further left on a number line or closer to 0, or if we're looking at negatives, the furthest to the left on the number line. So at the bottom of this page, you'll see some practice questions. If you want to look at these at home, you can. However, we will have time in class tomorrow to work through them together and see how you do with practicing your rational numbers.